Alright, and welcome to 2-4 Isosceles Triangles. Okay, so what is an isosceles triangle? Well, an isosceles triangle has two congruent sides, and I need y'all to write this down. Two congruent sides and two congruent base angles. And guys, if you are not taking notes, you are not learning. I can promise you that. So an isosceles triangle has two congruent sides and two congruent base angles. So what would that really look like? Well, let's say we had a triangle. Let's orient it like this. And I'll give two tick marks here, two tick marks there. And so basically, we have these two sides that are congruent to each other. And at the bottom, or we're going to call this our base, we have our congruent base angles. Now, you might be wondering, what is that third angle called? And so let me use a different color here. I'm going to use this orange, and I'll use two arcs here to show it's different. This third angle is going to be called the vertex angle. And you can think of the vertex angle as where the two congruent sides meet. Alright, with this new information, let's go on to our very first example. Okay, here we have our very first example, and notice it says this: given angle ABC is equal to 52 degrees. So let's see, I start at A, I go to B, I go to C, and I realize, okay, they're telling me that for this triangle, that's 52 degrees. Now, I don't have to be told this is an isosceles triangle because I see these single tick marks indicating that I have two congruent sides. Okay, so how am I going to tackle this? Well, we know that the angles of a triangle always add up to 180 degrees. So we will first start by subtracting this 52 from, and I want you to recall that this angle right here is our vertex angle. Okay, so we're subtracting 52 from 180, and of course, just using a little simple arithmetic here, we see that that is going to give us 128 degrees. Now here's the problem, because I want you to recall, what do we know about our base angles? Well, our base angles are congruent. So that means that this 128 degrees actually has to be split up evenly between the two congruent angles, so we will divide this by 2. And so 128 divided by 2 is in fact going to give us 64 degrees. So I say, okay, well that's 64 and that's 64. And our question was, what is the measure of angle BAC? So you'll notice that from B to A to C, we're asking about that one. It will be 64 degrees. Pause this, finish taking any notes. Let's move on to example 2. Okay, in example 2, it says find the measure of the vertex angle. And so we have to ask ourselves, well, where is the vertex angle of an isosceles triangle? Well, I see these two hash marks, which is telling me that ED is congruent to EF. And so, of course, this right here must be our vertex angle. So this is what we are trying to find. And by the way, our vertex angle could also be represented by angle DEF. Okay, so what are we going to do? What do we know? Well, remember, if this base angle is 25, then this base angle must also be 25. So we can do, okay, 25, my apologies guys, 25 plus 25, well, we know that that's going to be 50 degrees. Well, then we simply have to take and subtract this from 180, and we get the remainder of our angle, which would be 130 degrees. So guys, it turns out that this right here was 130 degrees. And a better question would be, did I draw this correctly? And the answer is no. 130 degrees creates an obtuse angle, and so our triangle would be better served to look something like this right here, where of course that is 130. Alright guys, I've got one more example for y'all. So go ahead, pause the notes, finish taking these, and let's move on to our final example. Okay, here in example 3, it says find the measure of angle YZP. And guys, as you go through these, I would always ask you to label this. So I see that from Y to Z to P, basically we're saying, hey, how big is this exterior angle going to be? Now we are also given this. We're given that XY is congruent to YZ. So let's see, here's XY, here's YZ. And if they're congruent, we can draw an equivalent amount of tick marks to show that they are congruent. Now this also implies, since there's 2 out of 3 sides that are congruent, that this must be an isosceles triangle. And lastly, the very last thing we know is that angle XYZ is equal to 17 degrees. So let's see, here's X, here's Y, here's Z. So we are saying that, hey, this is going to be 17 degrees. Now also remember that this is going to be our special vertex angle, and it's so key that you know that. That's where our 2 congruent sides meet. Okay, in order to start this problem, we first have to find one of our base angles. So how will we do that? Well, we know that all 3 angles of a triangle always add up to 180, and we are going to subtract off this one vertex angle that we know. And we are going to get, let me use this purple, we're going to get 163 degrees. So what is that telling us? That tells us that this angle right here and this angle right there, they are both going to have to add up to 163. Because they are congruent, we can simply divide this by 2, and this would equal 81.5 degrees. So I can write 81.5, I can write 81.5 degrees. Now from here, here's our very last thing. We are trying to find, in the gold, we are trying to find angle YZP. Well, notice that this is a straight line. That means that these 2 angles have to add up to, that's right, they have to add up to 180. So I can simply do 180 minus this angle that I found right here, this base angle, 181.5. And so 180 minus 81.5 will in fact give us, let me switch back to this gold, will in fact give us 98.5 degrees. And so it turns out here that this angle YZP is equal to 98.5 degrees. And there is our final answer. Alright guys, I hope that these 3 examples helped, and I'll catch you in our final video.